this?
With your calculator?
Yeah.
Oh man, I don't know. It's terrible.
Yeah, that's what I just did. You just break it
So
down,
for
though. Like 1 over e to the y squared.
Yeah.
I just grabbed it replacing like, I just used x's or y's and grabbed it.
Oh, and then turn your calculator sideways? No, 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 come on now.
What? It works.
So for
Okay, solve for y.
So
You learned how to do this one back in pre-calc.
Can you do those as LNs?
Yes, you have to take an ln of both sides. So I've got really, I'm going to go back to the original of e to the negative y squared. Take the ln of both sides,
That's a negative y squared,
ln of e,
which is
one?
1.
which is 1. So now I have ln of x is negative y squared. Negative ln of x is y squared. Take the square root of both sides. And ordinarily we need a plus or a minus over there. I think this is probably going to help us out in terms of what we need to look
Wouldn't
at.
you want
So,
that negative outside of the square root?
no, you can't take it outside of the square root.
I guess, yeah, never mind.
If you brought it out, now it's an I. Take the square root of negative 1. You better leave it underneath there so it's still a real number. Okay, so let's go to our graphing calculators. And we need to do the square root of negative ln of x. Let's start with the positive one. Just an ugly little graph. But since I only need to do the y's from 0 to 1, this is going to be good enough. And now I'm going to rotate it around the x-axis. So the rest of my picture is down under here and then fluffed out. Kind of looks like some kind of a mountain or something. I don't know.
So don't do this way.
Yes, the shells are going to have to come in this way because this is the axis of revolution. So you have to think about, no, I'm doing shells. I don't want to do discs.
Would this be easier?
No, it would be washer, wouldn't it?
I mean,
No, there's no hole in it.
No.
I mean, on the test, wouldn't this be easier if we were gonna choose like which is the easiest one here?
Oh, I see. Okay, we'll try, you'll see. Okay. I'm going with something like this, right? Something like that, and rotate it around there. So there's more of it down here. And when I've slided my little shell, there's the two sides of my shell.
It doesn't go all the way to 0.
Sure it does. Look at in the book. That's the best your calculator can do, but it tells you that the y's have to run from 0 to 1. And you can plug it. If y is 0, e to the 0 is 1. So when y is 0, x should be up at 1. And when y is 1, it's e to the negative 1, which is 1 over e, which is 1 over 2.728. It goes. It's just that's the best your calculator can draw for you. So my volume equals 2 pi RH. Whoops. And these are dy shells. The radius is always measured from the axis of revolution out to your typical shell. So here's my shell, xy. So the radius, yes, this time the radius is just the y value. And the height is just the x value. From here to here, that's x long. See why this shell method's so nice? Yes. The radius is always measured from the axis of revolution out to a typical shell. So in this case, this little amount represents the radius, but if you call that ordered pair xy, in the ordered pair xy, that distance is y. That distance is really the x value, whatever it is. Your little shells start at the axis of revolution and go up to the 1, so our limits of integration are really quite nice.
You have to change that x for y.
Replace the x,
E to the negative y squared.
e to the negative y squared. Now, you can do this one on your calculator, but look how lovely this turned out. This is e to the u. What would du be?
2y, negative 2y.
Negative 2y dy. We've got the y, the dy. All you're missing is the negative 2.
Well, you have the 2.
No, I don't have a 2.
You put
It's
it
not in
outside.
front.
Yeah, you put it back.
I could have put it in there, but okay. So now I've got negative 4 pi times e to the negative y squared, evaluated from 0 to 1.
I have a question, if you would have just thrown that, 2 back inside the.
Sorry.
Actually, yeah, you can
Yeah,
put it
yeah,
back
yeah.
in.
Oh, that's not.
Sorry, yeah. I need a negative 1/2
Yeah.
out in front. 2 times the negative 1/2 would be a
Negative,
negative pi out in front. Yeah, thank you. So e to the negative 1 minus e to the 0. So it's a negative pi 1 over e minus 1, multiply it out, whatever he does to get his final answer. Okay, now let's address where you wanted me to go. You wanted discs or washers.
Watch
Okay.
this.
Okay, discs. I need another page.